Hey there. Welcome to Short Takes 115. So this is the Physics 115 version of my Short Takes 331. And this is geared towards the students of summer edition of Physics 115. So the purpose of these videos is to go over very quickly the concepts and main topics that are going to be discussed in each lecture. So today, then, we're discussing day one on hydrostatic pressure. I will tell you what the main concepts are and what we're going to see in that first day of class. So the essential concepts are basically density and pressure. So we're going to be talking about fluids, and a description of a fluid requires us to define its density. So a density is a measure of the mass per unit volume. So it's usually some amount of mass divided by some volume. And so it has those units of, for example, a kilogram per meter cubed, and so on and so forth. And if you have a container that has, for example, a gas here made out of particles like so, there will be regions that have more density. There will be regions that have lower density. Now, in the fluids that we're going to be discussing, the density is going to be the same throughout the entire fluid. And usually when we switch from a fluid to another fluid, if there are two fluids in contact, for example, then usually the density will change in that situation. Now, the pressure is the other concept that you're going to be talking a lot about and working with. And the pressure is the measure of the force per unit area. And we're going to be talking a lot about this in class. The units for pressure are usually the Pascal. The Pascal is a unit of force divided by the unit of area, and so it's a Newton per meter squared in the International System of Units. We're going to talk a little bit more about this, but it basically means that when you're in a fluid, if you were to draw an area on a fluid, a geometric area, imaginary, then there's going to be some force that is applied to that area by the fluid, and so we'll be talking about pressure as characterizing that force per unit area. Um, a classic way to think about fluids is to imagine that there's a container. Here's the fluid in this hashed region in blue. And then suppose that we take an imaginary piece of that fluid and we say that's a volume V. And we're going to apply Newton's laws to that piece of fluid. And we're going to imagine that it's in equilibrium. And that's why we said this is hydrostatics. Yeah, so that means it's in equilibrium. And we're going to discuss in class what are the forces and what can we say about those forces based on Newton's laws? Yeah, based on the fact that the fluid is in equilibrium. So we're going to talk about that. And the main result that you're going to be using quite a bit connecting with this class and problems and so on is this one here. The idea that in a fluid, there will be pressure at any point in the fluid, and the pressure is equal to another pressure at a different point in the fluid, plus a term that relates to the density of the fluid, the gravitational acceleration. So we're assuming that the fluid is going to be on Earth. And so there's going to be the gravitational acceleration of Earth, which is, as you know, 9.8 meters per second squared. And there's going to be a depth. And this depth is relative to what? Well, relative to where this pressure was measured. And so, for example, we're going to be talking about the pressure at the bottom, for example, of this container. Then there's going to be a depth associated with that location relative to up here. And so P0 would be the pressure up here. This P would be the pressure at the bottom. And these two pressures are related by this term through this equation. Okay. Now, if you decide that your reference pressure is at the bottom instead of at the top, then you're going in the opposite direction. So the depth is not a depth. In that case, it's a height. So that's going to be a negative depth if you go in the opposite direction. So we're going to talk about that quite a bit as well in the first fifth class and beyond. Another important definition that supplements the concept of pressure is the concept of gauge pressure. So when you go and measure a pressure in real life, for a pressure of a car tire, for example, or a basketball, then what you're measuring is actually what's called the gauge pressure. And so it's the absolute pressure if you subtract the atmospheric pressure. And this is taken to be 101,300 pascals, so 101.3 kilopascals, which is about 15 psi, where psi is a pound per square inch. Yeah, so this is basically atmospheric pressure. It's actually 14.7, but we're going to call it 15 for the purposes of this short video. And so, as I was saying, this is the pressure that you usually measure with a manometer. Okay, so when you go and measure something, it's already relative to the atmospheric pressure. That's what you have to remember. So, for example, when you go and inflate the tires in your car, and you bring the pressure to 30 psi, that's pretty common, 30, 32, 33, then that's already relative to the atmospheric pressure. So in reality, the full pressure is the 15 psi plus this 30 psi. Yeah. So, but if you subtract the 15 psi, you are left with the gauge pressure, which you measure with your device when you go to the gas station to inflate your tires. So that's your 30 or 32, whatever it is that you put in your tires. That's it. So this is the end basically of this very short video. I'm not going to say much more. Just to give you a very brief set of comments and review of what we're going to be seeing in class the first day. I'm going to try to do this for each day of class. And so next time we're going to be talking about buoyancy. And so now you know, or you have a sense of what we're going to be covering, and which may help you perhaps with the warm up and so on. And so that's about it. I'll see you next time.